If I was to go to my periodic table right now and I look at the mass values that are given to me, some decimal point value, what you need to remind yourself is that that is not just of the element. It is the weighted average of all of the isotopes of that element. So if I had carbon, that mass, the mass value of carbon, the 12.01, that is the weighted average of all the isotopes of carbon that naturally exist. So when we're asked to calculate the atomic mass of the element based on the isotopes listed above, we do so knowing that we have to account for the percent abundance or the relative abundance given. So we multiply our mass value of whatever our isotope is, multiply that by the abundance of that isotope, and we're going to take the sum of all of those based on the number of isotopes. So in this case, we're going to do this 4 times, and this is what's going to give us our weighted average. Now, when you see brackets the way that I have written up there beside the x value, that's a way that we indicate an average value. So I'm going to I'll be calculating the weighted average of these 4 isotopes together. Now, the abundance should either be in a percentage value or in a value less than 1. So the abundances that are given, the 1.40, that should be a 1.40%, 24.10%, and so forth. Notice that the masses that are given to me, the label here is in grams. However, I'm going to be changing this to a unit of atomic mass units, or U. One thing that you should notice in your readings is that the molar mass and the atomic mass are the same value but different scales. A molar mass is more in the terms of a lot of molecules and the mass of a lot of molecules. The atomic mass is more of the weight of the mass of one atom in the context of that scale, such a smaller scale. So we'll be using U's rather than grams. However, either will work here. So the average atomic mass is going to be our mass 1 times our abundance 1 plus mass 2 times the abundance of 2 plus mass 3 times the abundance of 3 plus mass 4 times the abundance of 4. And I just want to remind you all about a percentage. 1.40% is the exact same thing as saying 0.0140. They work the same, and depending on your calculator, sometimes using percentages is going to be easier or difficult. I prefer to work with the decimal values rather than percentages, so you'll see me use the percentages here. So mass 1 is going to be 204.0 U's times 0.0140, which is our abundance, and then our mass 2 of 205.9745 U's times the abundance 0.2410, plus the third, which is 206.9759 times 0.2210, and finally 208.0 U's, that should be a U there, don't want to draw my units, times 0.5241. Now, while you're doing the problems yourself, you don't have to be as detail-oriented as I'm going to be, since I'm the one explaining this to you. However, as you're getting used to doing the calculations and being more prepared, I say write everything out and never, ever drop your units. Don't do it. Don't drop your units. They're never worth it. You need to keep those units all the time. So of the 4 values, the first parentheses comes up to be 2.856 to 3 significant figures. Our next set of parentheses comes out to be 49.639855 to 4 significant figures. Plus, the next one is going to be 45.741674, and that is going to be to 4 significant figures. Plus our final value of 108.992, and that is going to be to 4 significant figures. And they all have the units of U's. So the units didn't go away. They're all still the unit of the atomic mass unit. Now, the sig figs are going to be a little different because, as you notice, I listed 3 sig figs or 4 sig figs based on what I was given as far as the percent abundances. When you add or subtract sig figs, do sig fig rules, it's different than multiplication and division. So when I wrote down 3 sig figs for the first set of brackets, it's because I had a value of 4 sig figs multiplied by a value of 3 sig figs. So when you're doing multiplication and division, you keep the least number of sig figs. Adding and subtracting is a little bit more difficult. You deal with the last shared decimal place value and you truncate there. The last shared decimal place. Here's what I mean. I'm going to go ahead and in my calculator, I'm going to plug all of those 4 values in my calculator to get 207.2295285 U's. And if I look at every single one of these values, the first value was 3 significant figures, but it truncates at the hundredths place, at the 5. The next value was 4 significant figures, but it also truncates at the hundredths place. So if I was to add those 2 values up, I would keep everything until the hundredths place. The next value also terminates at the hundredths place, but the last value, which is 4 significant figures if we cared about that one truncates at the tenths place. So when you look at all 4 values, you look at whether or not they all share the last, you look at the last decimal place they all share. All 4 values have a value in the 10th place, but only one does not have a value in the 100th. So when we round this based on sig fig rules, we stop at the 10th place. So my average atomic mass should be 207.2 atomic mass units.